Hello, my name is Mofi, and you are here in the talk State of Kubernetes Observability. If you expect a different talk, you're in the wrong room, so we'll have to find a different room. But if you're for this talk, you're in the right room. I'm Mofi. I'm on the internet at Moficodes. If you need to find me for whatever reason, you can ask me questions. Yell at me for saying something wrong. All of them are fine things. That's a picture, like fairly old. I looked a lot better back then, so that's the picture I still use. And I am a developer relations engineer at Google. I mostly focus on GKE, batch workload, and observability to some degree. All right, so let's get started. Like any good talk, I'm going to start with the definition, because definitions are important. And observability, it's a noun, and the word means capable of being observed, which is a fairly broad and vague definition, but it's actually important distinction. Observability is not just knowing what's happening. It's the capability, if you needed to know what's happening, you could do it. So Kubernetes, by default, comes with kubectl, the CLI tool. You could always run the kubectl get to see how many pods are running. You could always do the kubectl describe to see what's happening on individual resources. But the term observability, it's not someone going in and typing in a command to run and see what's happening. It's someone just taking a glance at the state of the current thing and immediately knowing what's happening. If we extend the definition just a little bit more, it's also the system itself letting you know when something are wrong. That's when alerting and other things comes into play. So observability is a state where your applications and your clusters and your resources are not only working, but it's also telling you when it's not working. Why do we care? I mean, you came all this way to hear this talk. I came all the way from New York to come give this talk, so we definitely care a little bit. There are a few reasons. Obviously, performance monitoring. We're building applications. We want our applications to work well. We want to be able to know when that is happening. Troubleshooting. Things go bad sometimes. Things fail, things break. We want to be able to quickly and immediately understand why things are breaking and fix them as quickly as possible. Optimization. Sometimes we deploy a new application or our old application, we find out that using too much resources, can we do with less? So we try to optimize our application, and knowing where our bottlenecks are lets us do that. Capacity planning. And this is a fairly new world we're in with Kubernetes, because in Kubernetes, our nodes can be resized to right-size our application. So with monitoring and observability, we can understand exactly how much resources needed to run our application to the current limit. Security. This one is kind of like a tangent. So if you know that all of a sudden your application is supposed to use n amount of resources, all of a sudden that doubled or tripled, that could be a DDoS attack. That's a security threat that oftentimes we're not going to understand without having a full picture of what's happening in our resources. Finally, compliance. If you're in an industry like finance, healthcare, defense, not having a proper view of observability would be a bottleneck or almost a blocker for your customers to use your services. If you're financial services, there are different regulations by the government imposed as well as the industry that you have to showcase that you have those capabilities for people to even use your services. But why do we care really? Anyone has an answer for that? I actually have it, but I'm going to ask. Anyone has an answer? Why do we actually care?
My boss.
It's close.
We like cool graphs.
That's true too. But I think we care because of this, right? So observability is almost like having a car insurance, right? Car insurance is expensive, but not having it when things go really bad is way more expensive. So sometimes when you're thinking about observability and cost of things, you're like, oh God, this particular tool I'm going to use is going to cost how much? But then you have to always kind of take a step back and be like, if I didn't have this, right? To calculate cost of something that didn't happen is almost always impossible. But from years of experience, we know what happens when companies and teams and products don't have that understanding of how things can go wrong. So evolution of observability. We started, well, some of us started with servers back in the day, sysadmins. And those folks were wizards of magical folks that could read system logs and understand what the hell is going on with this system by reading just pure text. I can't even understand what's happening by reading text of a receipt. So those folks are better than I. But hopefully, and luckily, some of those folks felt that was a bit too much to be able to be reading a lot of these log things. So they started figuring out, okay, we have to kind of parse out some metrics, send out some metrics. so we can do some things. And then that led to the idea of performance monitoring. We can kind of tell what's happening in our system, how well it is performing, how much resources it's using. And in the world of monolith, if you did this much, you're probably already in a pretty good state because you can monitor performance, you're pretty good. But then we had the good idea to put everything as microservices, where each of our application would be a small chunk in a giant piece of application, and all of a sudden individual performance started meaning nothing. Because my checkout service is working well, but the user still can't log in. Nothing happens. So that's when we started to have to do things like system topology and interconnected mapping to know how service A is talking to service B. Service A is getting a lot of traffic. Service B is kind of slowing down. Database connection is not working. We have to do a lot more to get the same amount of picture that we had to do for a monolithic service. So finally, I think right now people are starting to see the last step for a good observability system, which is understanding and action. Right? I can show you, again, we like cool graphs as much as the next person, but looking at a cool graph and being able to tell, OK, this is what's wrong, and this is what I have to do to fix that wrong, is where I think we have to head towards to get better observability. So pillars of Kubernetes observability, or any good observability tool. Number one is metrics. You want some data. You want to know what's happening. Logs. You also, again, logs are old things, but they're still cool things. When things do go wrong, when things are going down, you do want to take a look at the log of what your application is telling you. Hopefully, your application is telling you something. Tracing. This is kind of new. It's when you are trying to understand in a more connected structure of microservices how a request goes through an entire system, and now you can find bottlenecks a lot easier. And finally, visualization. We like graphs. So you can kind of take a look with visually what's happening, because data is interesting, but visually we can correlate that data a lot better to understand exactly what's happening. So tools for Kubernetes observability. This is the hornet's nest I'm here to kick and see what happens. Again, if anyone looked at the CNCF, the whole thing, you know that we have inundated with choices, and there's too many sometimes. And this is me every time I look at it, because other than the few that are in the top, every single thing else kind of blurs together in my mind, and I don't know what to do. So when you're looking at observability tools, you have choices. Obviously, there are some CNCF projects. These are projects maintained and owned by CNCF, and contributors contribute from all over the place. You have member projects. These are companies that are member of CNCF, but the project itself is still owned by that company. And you have non-CNCF member projects. This is the rest of the world that exist. You also have proprietary solutions that manage services. I work for a cloud provider, so we have our own observability tools, AWS, and then Datadog, Dynatrace, Splunk. I'm missing about 1,000 of other names here. But they all exist. And they all do something because they're all making some money. So how do you go about choosing what you want to use? So if you take a look at the CNCF page just for monitoring tools, this is all the open source that exists in there, right? This is too small for you to even see, but there is many of them there. If you drill down a little bit more, this is all the open source tool and CNCF member projects. So it's still a lot. There's about, 21 there. And this is all the ones that are part of CNCF right now. Some of them do the same thing. So you got to figure that out, which one you want to actually use. So let's talk about a few of them. NetData is not a CNCF project yet, but it is right now the highest GitHub starred monitoring tool. So I didn't know about this until a few weeks ago, and I was like, why is this application so famous? So I started looking into it. NetData does something fairly cool. You just install an agent on your Kubernetes cluster, and it will go about collecting information, storing them, visualizing them as a one single package. You don't have to deal with multiple applications connecting them, so that's pretty cool. Only downside, in my opinion at least, is that the moment I installed the thing and I went to their dashboard, every 8 seconds they kept asking me to use NetData Cloud. And I was like, I'm here to just take a look. I don't make any purchasing decision. So the way this works is NetData agent itself is open source. You can install it, get the visualization yourself. But to be able to take full advantage of it, they also have a proprietary solution of NetData Cloud that takes all the data in. It is possible to take the data and pass it on to Grafana and Prometheus, but they don't make it easy by their docs. So if anyone here worked for NetData or something, if I said something wrong, tell me later. But from my understanding, by browsing the docs a little bit, it just felt like it was all a funnel towards pushing people to use NetData Cloud for the most part. And then I dug into some forums. It is technically possible to take the data out and use Grafana and Prometheus yourself. But it was not obvious from the documentation at the top. But again, still pretty cool. The UI, if you actually try it out, they have some demo versions online running. You can just go there, take a look at all the visualization. That just happens automatically. Pretty cool. I just would like there to be a little bit more self-managed version of it, which at the moment doesn't seem to exist. Next up is Grafana. This is, again, ranked by GitHub stars. And Grafana, who here doesn't know what Grafana is or haven't heard of it? Heard of it. Everybody probably heard of what Grafana is. Grafana is probably the dashboarding tool for Kubernetes, the de facto one. It started by Grafana Labs. Now Grafana Labs does like 20 other things, but it initially started with Grafana. And Grafana works really nicely with some of the other Kubernetes tools that exist, things like Prometheus. They have a bunch of collectors that you can send data to. Again, from Grafana, you immediately have to talk about Prometheus. Prometheus is probably the only tool on the list that seemed to be kind of common in every other stack that exists. We agreed that Prometheus is the way to go. It started off at SoundCloud as their way to monitoring their system, and it's almost entirely open source. There doesn't seem to be any managed version of Prometheus from Prometheus, the company itself. But there is a bunch of other Prometheus managed things from other vendors, Google included. We have something called Google Managed Prometheus, which is backed up by our Monarch database, which is the same database we use for monitoring like Gmail, YouTube, Maps, and all the other big things that Google does. But again, Prometheus is fully open source. And this is how Prometheus kind of works. You have Kubernetes, where you run your Prometheus server. And Prometheus has a pool model where you will create collectors that would like talk to your application to collect Prometheus metrics that your application exposes. And for things that does not work with the pool model, for things like jobs that might die at any time, you have something called the push gateway. So push gateway is a second service that you can run where your application can push their data up to the push gateway, and Prometheus can collect the data at some interval from the push gateway. And Prometheus, you can back it up against some SSD, hard drive, or persistent volume, and send that data off to Grafana or some other API client to monitor and create dashboards and visualize the information nicely. Now, Prometheus-related projects. So if you look at the CNCF dashboard, you're going to see a bunch of other projects at the top of the list. And if you read the documentation, they kind of blur together. I'll show you why. So Prometheus is hard to scale because, well, hard to scale horizontally. You can make the same Prometheus instance bigger, but running multiple Prometheus instances that work nicely with each other kind of is difficult. So for example, let's say I have a small Prometheus instance which is talking to one Kubernetes cluster. This works perfectly fine. If I want to make the same Prometheus talk to multiple Kubernetes cluster, I can make it bigger, make it like 128 gigabytes, or like as much resource I want to give it. This works fine as well. The problem starts when I want to say I want to have multiple Prometheus instances dealing with multiple sets of Kubernetes cluster. I don't really have anything that controls these two of the separate Prometheus instances that's running in two different places. So these are the next few projects try to deal with that problem. So I'm going to pause a second, and I'm going to let you try to read the description of these three projects. Take your time. Just read it. And tell me by reading that, how are they different? So I'm going to read it out again. So Thanos, open source, highly available Prometheus setup with long-term storage capabilities. Cortex, horizontally scalable, highly available, multi-tenant, long-term storage for Prometheus. Grafana Mimir. Grafana Mimir is open source, horizontally scalable, highly available, multi-tenant, long-term storage for Prometheus. And this is not me making up the definition. This is from the official website, the first line they put on their homepage. So this is what they say. So there is some drama here. Again, I'm bringing up the hot goss. So Cortex was the project initially started, and a lot of Grafana folks used to work on that project. And over time, from 2016 to until 2020, that's when Grafana Mimir started from the base of Cortex. So Cortex and Grafana Mimir having the same definition is kind of expected because at the lowest level, they have a lot of similarities because a lot of folks that used to work on Cortex now work in Mimir. So they have a lot of similarities. Thanos and Cortex plus Mimir had a different model where Thanos was doing a push-based metric system where Grafana Mimir and both of them, Thanos was doing a pull-based metrics just like Prometheus. Mimir and Cortex was doing a push-based metrics similar to push gateway. But over time, they both learn from each other, and now both system has both ways of doing things. So they have kind of blended together for the most part. Mimir is the newest, started in 2022. Cortex and Thanos are kind of similar time, couple of months here and there. Mainly, that basically goes to show that in tech, we are solving the same problem over and over again, and then after people get tired, we solve the problem again because all other previous solutions were bad. So Thanos, let's talk a little bit about more. So again, this picture, you're not going to see anything in there, but the basic idea is you have a query that queries all different instances of Prometheus at once. It takes all the output of different Prometheus structures, also stores them in a single location, in object storage, in buckets, wherever you want to do it. So Thanos kind of works as an upper layer on top of Prometheus, helps you manage multiple Prometheus instances at once. And the other model Thanos also has is the push model, where you can create something called the Thanos receive, where you can push your information into Thanos instead of Thanos pulling it automatically. So again, Thanos now have both ways of doing things. Also, complete aside, what's with all the tech things have a Greek name? Like, who started this? Like, anyway, so Cortex is another project. So now look at the image of how Cortex works. You have a distributor ingester from Prometheus. You're taking the data. And you have query frontend that is doing the query, sending the query back to Prometheus. And the image is drawn differently. But if you take a quick look at what Mimir looks like, it's exactly the same. Like you have query frontend, query push gateway, store gateway, ingester, object storage. It's just this was from the official doc. And this is something I drew myself. But it's the exact same thing. I'm just bad at drawing like they did. So. Again, they have very similar ideas, but I think Grafana and Mimir made some improvements because, again, they learned from 6 years of maintaining Cortex. They found all the things that were working poorly. They just improved those to make Mimir better. It's also open source. You can run that yourself, as well as they have Grafana Enterprise stuff that you can get managed services from them. All right, next up, Beats. It's not Beats by Dre. It's Beats by Elasticsearch. And Beats is a pretty novel idea. If you're in the Elk stack, you're the classic Elasticsearch, Logstash, and Kibana things, they have something called Beats now. So I guess this is called Belk stack. That was my Elk stack joke. So the Beats kind of works like this. Instead of having Prometheus as a single thing that does all the metrics, in Beats, you can have a collection of bunch of open source small tools that does individual things. So you have something called the audit bit, metric bit, file bit, packet bit, heartbeat, and Windows log bit. I think the entire thing started as just the heartbeat part, and it kind of went out of hand because they like the name heartbeat, and they're like, okay, we have to make everything into a bit. And you have something called libbit that is the interface that you can build your own bits around. Like if you have a specific type of data you want to collect, you can build your own plugin with libbit that can send the information to Logstash and Elasticsearch that can take the data and put it on Kibana, make nice dashboards, graphs, yay. All of these things play pretty nicely with each other. If you have data in Elasticsearch, you could technically take them and put it on Grafana, because Grafana also has collectors for Elasticsearch that can display Elasticsearch data. But ideally, what would happen is if you're already using Elasticsearch and Logstash, the hope probably is you're going to also go for Kibana because they play nicer with each other because they're the same group of people. But again, if you want to look for like a complete architecture of like a observability, this is a fairly nice stack. All of them can be managed yourself. I looked at their docs. They seem to have a lot of push towards Elastic Cloud, but at the same time, they have nice documentation where you can run and manage it yourself. Weaveworks Scope is a bit of a different approach to the same idea. The way this works, Weaveworks is a company that does a lot of networking stuff. So they build a tool called Scope, which runs a probe in each of the nodes on your cluster, and it catches network packets as they come through, collects information from there, and push it off to an agent that can now, they have a dashboard that you can see what's happening in your node level and container level. If you didn't know this, in Kubernetes, every container is just a process. So if a system can capture packets to understand what a process is, that immediately can understand what containers are running and how much things are being used and all that at the node level, which can create a pretty nice dashboard for you. And you can also set up things like alerting and other things on top. I haven't looked too deep into how Weaveworks Scope data can be passed off to somewhere else, because I think the idea of Weaveworks Scope is more about having like a standing dashboard that's running in the background. You can just take a look if something is red and do something about it. Pixie, this is one of the newer ones. There are a few more on this category, and I only expect this to grow over the time. Pixie is a project that deals with the same idea. Instead of doing network, though, it deals with eBPF. So it has eBPF probes in your node that is installed as daemons and agents. And as things happen in your cluster, eBPF probes can capture those and create dashboards and give you data. One nice thing about Pixie, well, not nice thing about Pixie and nice thing, they have a custom script called PXL. You can write your custom script to collect information exactly the way you would want it. But that also means you're going to learn a new set of tools, new set of tooling to manage Pixel script. And be like, as time passes, that's going to become like a whole thing to manage and maintain. But for the most part, Pixie is pretty nice. You have a CLI tool that you can use to install the agents. They have a dashboard, but you can also take the data and pass it off to some other tools like Grafana and Prometheus to show them somewhere else. But ideally, again, all these tools, many of these open source tools, the main idea is you'll use them in open source world. You'll try to manage them, and 3 months in, you'll feel like, OK, it's impossible to manage it myself. I'm going to just pay them some money to do it. Not saying it's a bad thing, but that seems to be the general trend in a lot of these tools. Open source logging. So again, this space, again, just after you get out of monitoring, the space kind of shrinks quite a lot. For logging, you don't have as many. Either we think logging is a solved problem, or people don't really care. Logging is not as cool as it used to be. So the set of tools we have Grafana Loki, Logstash, FluentD. FluentD is the only tool in this set which is CNCF graduated. So it's one of the first 10 CNCF projects almost. And FluentD, the company, since then have done a couple of other things. They have created FluentBit, which is FluentD, but written in Rust, because all cool things are. So these are the open source and CSCF member projects. So you have Grafana Loki, Logstash, FluentD, OpenSearch, and Logi. The last two, OpenSearch and Logi, are fairly new compared to the other three and is not as popular. So I only looked at the first three. Again, FluentD is the only one that's graduated CNCF. And the other ones are not even part of CNCF yet. They're just CNCF member projects. So Grafana Loki. It's a pretty simple idea. You have your data. You have Promptail that's collecting the logs, sending off to Loki. You can send the data off to now Grafana to showcase the logs, or log CLI to see the logs yourself, or send it to Alert Manager based on certain criteria. Again, log systems seem to be a lot more straightforward in kind of how they operate. Your application generates logs, your system generates logs. They would just collect it and send it off to somewhere else. Logstash, again, elk stack. If you're in that world, Logstash will do the similar things. So again, you have multiple bits, file, syslog, Redis, or other bits. And Logstash has concept of filters, grokking, dropping, mutating, and GeoIP-based calculations. So as you send the logs, you could do things like filter based on certain criteria, or drop based on certain threshold of rate limiting, and then send it off to other things, like you can store it to a file, send it to Elasticsearch. Graphite is a very old system that used to exist. I never have seen that in the wild, but people might have them still. And statsd, you can, oh yeah, we found one. Oh, more, okay. Cool. I'm getting schooled here. But yeah, Graphite, again, it's a fairly old. I think 2004, 2005 is when it came out. So it predates cloud almost. So, but again, if it ain't broke, don't change it. FluentD, again, very similar idea. You have a bunch of logs coming into FluentD. FluentD has concept of filters, buffers, and routing. So you can take, based on features of the log itself, you can send the log to different places. You don't want all of your logs to be stored long-term onto your object storage. So you can create some filter rules in FluentD and send them to right places. Tracing tool. I have a Jaeger hoodie that I'm not wearing right now, but Jaeger, this is one of the way to trace. Trace has been an idea for a long time, but for the longest time, we used tracing or things like flame graphs to understand how our application performance worked. But with the emergence of cloud and microservices, tracing became more and more important because we needed to know how our request traversed through our entire system and find out where the bottlenecks were. So traces, for the most part, looks very similar to flame graphs because you get to see, OK, this particular thing took this much time, which is very reminiscent of flame graphs if you ever looked at one. So again, if you're looking at open source and CNCF member ones, Jaeger is a graduated project, which is really good. Open tracing used to be the de facto standard, but then it got deprecated in favor of OpenTelemetry, which is the newer version of similar things. The same people that used to work in OpenTracing now works in OpenTelemetry. I don't know the full details of why that decision was made, but I have to guess there are certain design decisions in OpenTracing. Those are hard to reconcile back with the current state of Kubernetes. OpenTelemetry, more people got together, learned from their mistakes, and did it better, hopefully. We'll learn in 5 years when a new standard comes along. So Jaeger, OpenTracing, and OpenTelemetry is the 3 CNCF projects that are part of CNCF. Again, OpenTracing right now says archived. If you go there, it will still probably work if you really work really hard to make it work. But all the same functionality is now in OpenTelemetry. So you should probably just look at Jaeger and OpenTelemetry. Jaeger. So Jaeger started as a project in Uber, mainly by Yuri. So he used to work at Uber at the time. And he just built that thing, and Uber claimed, like you do, that we did it. So Jaeger is a tool where you can have this thing called a collector that collects traces. You can create things like, there was a workshop like on Wednesday in this same room. We had like a Jaeger workshop. So you should have all gone back in time and gone to the workshop to learn more about Jaeger. But you didn't do it probably, so I'm going to just tell you what it does. You have a Jaeger collector, and you can set up programmatically traces and spans on Jaeger. And as the application runs and it traverses through, your application will send those information off to Jaeger collector that will create this flame graph for you, for your application traces. Back in the days, Jaeger used to have clients that used to do it itself, but they had this brilliant idea, which is actually not sarcastic, actually a brilliant idea, of using the OpenTelemetry collectors. So Jaeger now plays nicely with OTel logs and metrics, so you don't have to maintain multiple sets of telemetry. You can just set up your application to do OpenTelemetry stuff, and you can use it down the stream with Jaeger, with other tools that understands what OTel metrics look like. But Jaeger is pretty cool. It works fairly nicely with Kubernetes. It's well supported. And there are a bunch of other tools, like Grafana actually has a collector for Jaeger. So if you create Jaeger logs, instead of having the Jaeger dashboard, you can put everything up to Grafana. So you have a single place where you can see everything. OpenTelemetry, as I said, is the new standard where all of the work is being done. There's a bunch of client libraries. You can create your own by just creating HTTP stuff. But if you're using any of the popular languages from Java all the way to Rust, you have something you can just download and use. Again, OpenTelemetry are just all APIs. So even if your language didn't support it, you could just make API calls to send the information yourself. But that's going to be more annoying to do. So there are nice libraries for most used languages. So this is kind of how it looks like, Kubernetes and cloud providers. So there's a language or specification called OTLP. And there's an OTel collector. You can send that off to OTel collector. And the collector can send the information off to time series database, trace database, column stores. However you want to store it, you have ways to do it. Because, again, it's just raw JSON data. And tracing tools have the understanding of how to take that data and show you nice little graphs. Next one, chaos engineering. Again, I didn't initially consider chaos engineering as part of observability, but if you really think about it, how your system behaves on failure is just as useful to know how your system behaves when things are going well. So chaos engineering, back in 2014-15, it seemed like that was going to be the whole new rage. Then people actually looked what chaos engineering actually asks you to do. It asks you to sometimes randomly kill some of your services and see how it works. And most enterprises were like, intentionally introduce failure? It happens automatically, and you have no way to stopping this now, and you want me to do it intentionally? So it has not taken off as big as we initially thought it would, but it still exists, and it's a great tool for testing certain things, for testing things like how long it takes for your system to recover, how does your alerting system work, and things like this are pretty good. So there are few big projects in the space that are part of CNCF. We have Chaos Mesh, Chaos Blade, and Litmus. Interestingly enough, Chaos Blade came out of Alibaba Cloud, so most of their official users happen to be in the Asian community. Their official docs is in Chinese. So, but again, you can pretty much use any of them. Chaos Mesh and Litmus is, again, in English. You can pretty much read the doc and understand what's happening. The concept is fairly straightforward. You have your agent that's installed, and you can have some, set up some configuration. And based on that configuration, the agent can introduce pod failure. It'll just start deleting pods randomly and let Kubernetes handle restarting of the pod. And you can then down the stream take a look at what's happening when those failures get started. Litmus is another project. Again, very similar idea. You have a chaos engine that has a configuration. You set up the configuration that based on the configuration, it will start deleting things randomly. It does more sophisticated things, but at the 10,000 feet view, it just deletes things randomly and see what happens. OK, and open source continuous optimization tools. We have someone from KubeCost in the audience. So KubeCost is probably the bigger, one of the only players in this space. Understanding how much money you're spending in your cloud is a big challenge. So every cloud provider has some sort of billing stuff, but then a lot of people are multi-cloud. We have people that are trying to run multiple clouds at the same time. Figuring out how much money you just spend trying to, I don't know, change your V1 to V2 is important because, again, you remember why you do observability? Money. So this is the part where we actually think about money. So OpenCost is the CNCF project, came off KubeCost, got donated to CNCF. So now it's two separate projects, but also maintained by the similar group of people. So it's kind of same, a little bit different. KubeCost is the managed service where you have a lot more features and things. But OpenCost is open source, maintained by the community, has very similar concepts there as well. So KubeCost, you have KubeCost agents that are running, and they have APIs to talk to your cloud provider like AWS, Google Cloud, Azure. And they also have information of the cloud billing API where they could look at how much of your cluster per namespace is being used and map it to how much cost that there was to do per namespace cost. I'm probably glossing over, and I'm just looking at that side for nod of approval. So if I don't get nod of approval, I know I'm doing something wrong. So if you want to know more about KubeCost, I'm not an expert. Ask Matt, you'll learn a lot more. But the main idea is they're doing some clever things internally to kind of figure out, OK, this is how much it initially cost for the billing API, but after discount and all this stuff, this is the final bill. You use 7% of the total time of the cluster, so this namespace probably cost you $7 out of $100. Very roughly what it does. But again, you get nice dashboards, nice understanding of how breakdown of things, and you can use that information to do bill back to individual teams, or like associate workload to individual teams to find out which team is the biggest money sink. No, don't do that. OK, OpenCost, again, it's an open source spin-off of KubeCost. I don't know exactly when it happened. Matt can answer that better. But it happened at some time, and it is maintained by the same group of people. But like the clear divide is probably making it easier for them to add a lot of enterprise features for KubeCost. And OpenCost is now going to be maintained and grown by the community. Finally, some non-open source. This is your cloud provider maintained ones, like Google Cloud One. This has to update to Operations Suite because it's no longer called Stackdriver. We like to change things sometimes because it's been a while. Amazon has one. Azure has one, obviously. You have all the managed ones like Instana. We have New Relic. We have things like Datadog, Dynatrace, Chronosphere. All the big players you know, and the commercial you see in the airport, they're here. You have seen those, like the monitoring commercials in airports, right? Yeah, those are all here. I don't know why airport. Like, what is the goal there? Logging tools, again, Elastic is here. Splunk, obviously, is here. Sumo Logic is here. Tracing tools, Honeycomb, Lightstep, they're doing cool things. I'm not going to dive deep into like paid managed systems. If you're already using it, you know how good or bad they are. And they are doing some cool things, obviously, because it's proprietary. They can probably innovate a lot faster. Open source, you have to talk to like 50 other people to decide on one line change of code. They could probably do this, just I'm going to do it kind of a decision. Cost optimization tool, there are a few. I have not seen any of them in my life before. So they're probably doing cool things, but I don't know. So common stacks, like there's a lot of tools. If you just go about trying everything, I tried most of them for like hour, 2 hours. The ones I use daily, but the ones I didn't know, I tried them out. If you want to actually become an expert in all the tools before you decide, it's going to take you probably 6 years before you're done. By then, there will be like 20 more tools that you have to go back and learn. It's a whole cycle. You're never going to get through. For most use cases, you can pick a couple of like common stacks that just kind of works. So the most classic one probably would be Prometheus Grafana OpenTelemetry. Prometheus is probably the only common thing across all observability things in Kubernetes. But you have Prometheus collecting logs. You send them off to Grafana, OpenTelemetry for traces, send them off to Grafana or Jaeger. it looks something similar to this. You have Prometheus, Fluentd running for logs. You have OpenTelemetry collecting the traces, sending off to Jaeger, Grafana for all the dashboard stuff. And this would be something you can probably manage fairly okay. It's not that bad. But again, managing all these different versions as things change, maintaining, updating things can get complicated. Elastic Stack, we saw this already, like all the Elastic tools, you manage and run that yourself, and if when you get tired and no longer want to do it, pay Elastic some money, they'll do it for you. That works pretty well. Grafana, over last 5-6 years, they pretty much have every single tool in that space that does different things. They have their own version of it now. So you have Mimir for managing Prometheus, you have Grafana for dashboard, Loki for logs, Tempo for traces, so the same thing that Jaeger does, Tempo can take OpenTelemetry logs. So if you're interested in Grafana stuff, if you pay them some money, they'll let you do all these things. Even if you don't pay them money, you can do that yourself. So Grafana is pretty cool. So now the big question, how do you go about choosing the right tool? So this is where I'm going to tell you like my strong certified opinion, and you're going to exactly know what I tell you to do. No, I'm not going to do that. So choose open source, self-managed, if cost is a major concern. You are concerned about, okay, paying a bunch of money to a company that you have not tested yet. Your team has enough bandwidth and scale to be able to actually take on managing a whole like an extra project on top of Kubernetes. Want to be in the cutting edge, because open source sometimes are doing new cool things. That might be something you want, and you want this new feature that your managed service has not caught up to yet. So this is something you probably want. And finally, don't want to lock yourself into anything, not even the project you're using right now, because it's open source. You can just like kubectl delete that tomorrow if you want to. So this is, again, for the brave and the frontiers of the world that are going to try like create a whole new stack yourself using open source tools. Choose a cloud provider solution. Again, I'm a cloud provider, work for a cloud provider, so you might want to do that. Again, there are reasons you might want to do it. You're only on one cloud, and you get a clear price advantage by bundling. If you get like their Kubernetes, object storage, you get their databases, now also throw in their monitoring, you just add a little bit of extra cost, you get a huge discount because of it. Sure, that makes sense. Better integration with existing infrastructure. So if you're, for example, in Google Cloud with our operations tools, all the other things you use like BigQuery, databases, all of them can fit their data into your operations suite. You don't have to worry about, okay, how do I connect this thing to this thing? How do I maintain logs, traces, all this other fun stuff. So that can make sense if you're on single cloud, you're only using that cloud provider stuff, and you want to not worry about anything else. Managed service can make sense if your infrastructure is hybrid, if you're on like 4 different clouds, and this Datadog sales agent said they can handle all clouds that exist in the world, that could make sense. Your team does not have the bandwidth to self-manage an observability stack. And that's a real thing. If you're an application team, your responsibility is run the application. You don't expect yourself to become the expert of running the application and also managing 7 other different tools that are kind of do the same thing but a little differently. And you're looking for features that are only available in the managed service. I didn't finish that sentence. But the idea is, like, let's say Datadog is doing something that only Datadog does, or Instana, or Splunk, or one of those tools are giving you something that only they can provide, and you need that feature. So the only way we can get that is by paying them some money. And finally, I think a lot of people are in this world right now, which is you want to use an open source tool, but you just want to pay some money to the people that made the open source tool to manage the thing. Because again, they're the experts. They built it out. They know how this thing works, and they know how it breaks. And you can take the cognitive load of taking the understanding of the system from your brain and offload it to them, and they can do that for you. And this can make a lot more sense because you don't want the vendor lock-in, so you're using an open source tool. You also have the power eventually once you figure out, okay, now I can manage a Prometheus instance myself, I can always cut that and move to my own Prometheus. You're still using the same open source standard. So this might make a lot of sense for a lot of teams. So these are probably the 4 big options, and your truth lies somewhere in here. Hopefully, if it doesn't, talk to me. I want to know what magical application you're building that is not covered by any of these 4 options. And the 5th option that I'm not going to even talk about is building it out by yourself from scratch. Don't do it. This is the only opinion I strongly believe. Don't build new things from scratch unless you plan to open source it. Final thoughts. Observability is expensive, but not having it is going to be more expensive. So oftentimes, the moment you hear about a bill about something that doesn't immediately do something for your application directly, you're like, why am I paying so much money for this? Just think of it as like car insurance. When your car actually breaks and you didn't have the car insurance, it's going to be way more expensive to fix it. We have many choices. That means room for many mistakes. I will not stand here and be like, this is the right way and this is the way you should be done, because every application teams, and depending on kind of the makeup of the team itself, the choices will be different. And you will make mistakes because we don't get it right. We continuously improve it to get it right. This is the DevOps journey. We do things are wrong, we improve, and we do things a little bit better the next time. That doesn't mean you go into perpetual motion of just trying out new tools and never get anything delivered, because that will get you fired. So what you want to do is try out some of the community mandated, like recommended things, test it out, see how it goes. But as you find out things are lacking, don't just settle for something that is missing features. Look for better alternatives, because that's how we got into the situation where we just accepted things the way they were. We make changes because we want to improve things. And engineering hours spent is money spent. Sometimes we go like, okay, this is free, but 7 of my engineers has to spend full-time hours in making this thing run. You pay those engineers unless you found them for free. If you did, tell me where you found them, because it's cool to find free engineers. But no, if your engineers are spending actual daily time in maintaining this system, you are technically paying for these systems. But instead of paying the company that can do it probably better, you're paying engineers that could have actually worked on your application. So managed services can save time and headache, right? Like, it's always fun to have someone else to yell at when things go wrong, instead of having to yell at your own teammate, which can suck. You don't want to do that. So with that, thank you so much. You can find me on the internet, Mofizur. If you have any question, we're going to pass it off.
I apologize for being late and not being able to make things work, but 2 things.
Yes.
If you ever quit tech, you could go either into tobacco auctioneering, or, because that was one of the fastest deliveries I think I've seen here. And the other thing is late night comedy. Think about
thank
that.
you. Well, I have answer for the first one. I have a flight from LAX at 3 p.m.
Oh, but you know, some people can't get the information out under that situation.
Oh, yeah, thank you so much.
So
I
give
appreciate
them a
it.
hand for that, too.
Thank you.
Okay.
I explained it so well. No one has any question. It's done. Everybody knows observability now. Next year we come to scale, we're going to completely cut out the observability track because everybody got it. Yeah. Any questions, comments, things worked for you? Didn't work for you? Horror stories?
Yeah, this was pretty dense. I mean,
Fantastic.
I can't wait to see the sequel.
Yeah, State of Observability Part 2. We're going to do 10 parts of it.
So I actually didn't get a chance to look at your bio. You're at Google?
Yeah.
Oh, okay.
Yeah.
So I couldn't ask you what your preference was.
You could.
I could?
Yeah, for sure.
Would I get an answer?
You would?
Okay. What's your preference?
I think this probably is my actual opinion about things. It's a bad answer. It depends. But I think it makes sense if you're all in AWS, which is a lot of folks. And it makes sense, you get a really good price advantage by using AWS CloudWatch, use it, right? Like, I would rather have people use the services that make sense and lets them grow their company, because eventually you'll get to a size where one cloud is no longer enough. Choose us for the second cloud. We're okay with that. That's fine. Or if you're already on Google Cloud, thank you. And you can use Cloud Ops. We can do some really cool things. But it's obviously a choice you have to make to see, okay, Cloud Ops can do these things really well, but I think Grafana is doing some cool things, and I think it's going to be better for my application if I were to use Grafana for my solution. Use Grafana, right? Like, I think there is enough work and money to be made for everybody in this space where I don't have to go like, oh, use this or you are wrong. I don't think that is going to be a stance I will never take no matter who I work for.
Right.
A question over there. 4 minutes, yeah, that's good.
Okay, it will be short, but I thought now that you say this, that there is a hybrid solution. So you use an open source version, which is managed by the cloud provider. Grafana managed by Google or AWS.
That also exists, right? So I think for the majority of the folks, barring doing it themselves, which a lot of folks seem to think they're going to be better at doing than the team that actually made the product for some reason, I think this is where most of the truth lies, where you like this open source project, that you played with it, you think this satisfies your application needs, but managing and maintaining and actually spending engineering hours in managing yourself is not worth your time. It's probably cheaper to then just pay the company, either your cloud provider or the company like Grafana or Elastic, or name another provider that gives you this managed open source version. This is the one I'm most excited about, because this means, because for example, doing open source is very difficult, like maintaining and running continuously, improving an open source project. So if you can get to a place where people that are doing the open source project also can make money by doing a managed service of the same thing, but not dilute the quality of the open source, I think that's where we're going to get the best value for the community as a whole long term.
And if you have a great tech PM, he's got a spreadsheet, and all of this is going in there if it isn't already.
Yeah. Thank you so much.
Thank you.